Okay, welcome everybody. Thank you for coming to the talk today on AppFabric caching. My name is Jason Roth, and I'm a principal programming writer at Microsoft. And what that basically means is that I'm responsible for producing and managing a lot of the content associated with AppFabric caching that gets put out on MSDN library and some of the other web properties that we have. So hopefully, if you're using the documentation, that's a good thing. But if not, I'll do my best in this talk. So what I'd like to say today is that I think that everybody here has a scalability problem. We either have a scalability problem that we know about, or as your business grows and as your application users grow, you'll have a scalability issue someday. And AppFabric caching is a technology for .NET applications to improve the scalability characteristics of your app. So what we're going to cover today is presenting AppFabric caching as a solution that you can either implement today in an application that's experiencing a problem, or one that you can put into a design for an application for the future, for a new application. So I have two things for you today, two main things for session objectives. The first thing is a methodology. You say to me, hey, I'm interested in AppFabric caching. I'd like to use it. What are the considerations? The considerations may be high availability, the number of objects you have, the size of those objects. There's a lot of different types of questions that you have to ask to answer that question. And what I'm going to present to you is a methodology that systematically shows you what the questions are and provides some ways of thinking about those answers so that you can then come up with estimates. You can come up with an estimate for how many servers you need, how much memory you need, how do you actually determine what AppFabric caching features you need. So that methodology is the first thing. The second thing is more basic, but I think it's just as important, and it's the existence of two white papers. There's a white paper that a partner of ours, Grid Dynamics, produced, and it's on performance and scalability numbers. They did a lot of testing. They have a lot of data out there. If you know about that white paper, you can go and look at it, and it can inform some of your decisions. It can also validate AppFabric caching in terms of how it scales, how it performs. Is it going to meet your expectations? The second white paper is one that I wrote along with some colleagues of mine at Microsoft, and it covers a lot of the methodology that we're going to cover in this talk today. And the great thing is you're going through a lot of sessions at TechEd. You are filling your minds up, and it's really hard to retain all of that information. If you know about those white papers, you know you can go back to those later, dig in a little deeper, get a little extra information that's related to this talk. So if this talk interests you, if it's something that you think you'll need and use, then you can use those white papers at a later time, a week or two down the road. This is not really a technology deep dive session, but we are going to cover the basics of what AppFabric caching is, because we're not all at the same place in terms of our understanding of that. So the way we thought we'd organize this talk is to present to you some common questions that customers have that relate to capacity planning and planning for AppFabric caching in general. Obviously, if you're here and you don't know what AppFabric caching is, your first question is going to be, what is it? And do I even need it? Do I want it? And I'm sure there's some of you out there like that today, so I'm going to cover the basics of what AppFabric caching is. Then you might wonder, are other people using this today? Are they using it successfully? Well, they are. I'll cover two examples. There's lots of other examples, some that I can't share. But customers are using this today in production, and it's helping people to create more scalable applications. The actual methodology, the systematic set of steps and questions that we're going to cover is in the third question, which is, for my scenario, how much memory do I need, and how many servers do I need? And then there's other questions you may not even know to ask, such as, what kind of network bandwidth do I need, or what kind of AppFabric caching features do I need? So that's the bulk of the presentation in terms of the capacity planning methodology. But I may come to you and say, well, based on everything you've told me, you need 4 servers, you need 16 gigabytes on each server, and you need 1 GBPS network cards on each server, and you should be good. Well, you still may say, really? Am I really going to be okay? How do you prove it, basically? And that's where that Grid Dynamics white paper comes in, and I'll share some of the results from that white paper in this talk, but you can look at the detailed results on the web. And then finally, once you come up with an estimate, no matter how well I present this information or how well thought out these steps are, it's still an estimate. It's based on data that you've come up that you've estimated and pulled into a larger estimate. And so we're going to have to verify this. So in testing, what types of performance indicators do you look at? How do you spot that you've potentially underestimated the amount of memory you need or that there's a problem? So that's where the bulk of my demos are going to come in. We're going to go through, at the end of this talk, several different scenarios to both reinforce some of the AppFabric caching features and also show you some problem scenarios and what it looks like. All right. So let's look at the AppFabric caching overview. The problem scenario basically goes like this. A lot of applications that are distributed applications have multiple servers. In a web application, these would be ASP.NET web servers, potentially. Or they could be services. I just wanted to call them app servers. You have multiple users coming in being distributed to one of those servers for processing. And there's a need to store reference and activity data. So I may have a product catalog I have to access. I may have a shopping cart that I need to store. Regardless, I go to the database typically for that sort of activity. Now, as you increase users, you have an increased need to scale the database, and you'll have to scale the database up potentially. One solution is to have a local store. Use the local memory on each server to cache some of the data from the database. So that way I'm not hitting the database all the time, and I'm storing some of the data in memory on each server. You could do that manually, or with ASP.NET, you could do that through session state. But the problem we have is that if a user comes in and you're storing some of their data on one of those servers, you have to have sticky routing. And I'm sure most of you, a lot of you are familiar with this. They have to go to the same server every time so that they can access the memory on that server. One of the solutions is to use another database for caching. So now I have a database for my primary information. Maybe I have another database for caching information. But you end up in the same place. Your database must scale. The database sort of becomes this point of scalability. So how can we have a design that's more dynamic, that is more flexible to handle increases in users in a better way than just relying on the database or relying on the memory on each server? And that's where we think that Windows Server AppFabric caching comes into play. Windows Server AppFabric caching is a distributed in-memory caching solution. So it's distributed because you have multiple servers that make up your cache. And if you need to, you can dynamically add additional servers to add additional memory to your cache. But from the application's perspective, it's all seen as one entity. The application writes to the cache as one entity, and the cache handles load balancing your requests across all of the servers. It's in memory because it's all in the physical memory on the box. So it never goes to disk, or it would basically destroy the performance characteristics. So let's look at one scenario with reference data. Let's say you have a product catalog in your database. The web application can get that product catalog, and then it can store that into the distributed cache. Okay, so in the future, I'm going to refer to this as a cache cluster, because that's what it is. So we store the item in the cache cluster. Because it's a cache cluster and AppFabric provides additional features, you don't have to implement this. You can just sort of turn it on, and you could have high availability. And it will copy that item to another server so that if the one server goes down, the item still exists on another server. That's one of the features, a more common one. And then when the web service 1 needs the same information, instead of going to the database, it can access it from the cache and use it directly. So the load on the database is decreased, but you have this pool of memory across servers that you can dynamically add servers to, and it becomes a dynamic solution for scalability. So that's Windows Server AppFabric caching. We released that last year, almost a year ago exactly. And you can download that on the Download Center and install that and start using that right away. Now, this is an on-premises solution. You own the servers, you set up the servers, it's all on-premises. I forgot to mention there is local cache too. Local cache enables you to get the benefits from local memory on each server, each web server or application server. And if the item is not in the local cache, it will go to the cache cluster. And so it basically refreshes items from the cache cluster into your local cache. So it's just another feature that's built into this solution. Now, as I said, that's an on-premises solution. Windows Azure AppFabric caching is, as its name suggests, caching for the cloud. So you take this concept of the distributed in-memory cache, and you put it in the cloud. And I want to stress that Azure AppFabric caching is for Azure applications. You may be tempted to think, oh, I'll develop an on-premises application, and I'll access it in the cloud. You can do that. The technology lets you do that. But the latency from going from on-premises to the cloud is probably not going to be what you want for your on-premises application. It's good for testing. It's good for debugging. It's not so good for production. So we don't support that as a production scenario. But if you're developing Azure applications like ASP.NET hosted in the cloud, then Azure caching is just a logical, really beneficial technology to put in the cloud, and that's what we did. So obviously, you don't have to set up any servers. You don't have to allocate any memory. You just pick your cache. You pick what size of the cache is. You can go up to 4 gigabytes today, and then you start using that in the cloud. Now, our talk today is going to be on Windows Server AppFabric because it's a little more complicated. You're in charge of more moving pieces. You're in charge of figuring out what servers you need, how much memory you need. So we're going to look at Windows Server AppFabric, but it doesn't mean that some of these concepts don't apply to Windows Azure AppFabric. Some of these concepts still apply. So just keep that in mind. But from here on out, we're going to talk about Windows Server AppFabric. OK, so are other customers using this in real-world applications? Let's take a look at that. I've got an internal example here and an external example. Internally, inside of Microsoft, the MSDN forums decided to adopt AppFabric caching back when it was a CTP. They realized their databases were heavily loaded with forum-related requests. So you'd go up to the MSDN forums, you post a question, somebody posts an answer. There's a lot of activity across a lot of forums with a lot of users. And what they've done is they've used AppFabric caching to reduce the pressure on their database server from 80% to down to 10%. So they had a really positive outcome from using caching there. And they have 27 gigabytes of data across 4 cache servers. And they now support 1,000 reads per second and 200 writes per second. Externally, we have a case study for AP. And Associated Press used AppFabric caching to improve their resource utilization and also to have 50% faster response times. So I think all of us, most of us, know caching is a good solution. And the question is, how are you going to cache? And in these cases, the customers, and both Microsoft and externally, have used AppFabric caching. I'd like to point out that there's other customers here. Some of them we aren't permitted to share with you. But we do have a lot of success stories with AppFabric caching. And a lot of that has come through our Microsoft Customer Advisory team. I don't know if you've heard of that before, but our CAT team will work directly with customers. And they'll find out best practices and where customers are having problems. And they'll feed that back into the product team. And we'll improve the product. But we'll also come out with lessons learned like I'm sharing with you today. So a lot of what I'm sharing with you today is the result of direct customer interaction. All right, so you've heard a little bit about what AppFabric caching is. You've got a background on what it does. And you see other customers are using it. If you're interested, if I've kept your attention this far, and you think you might want to use AppFabric caching, then the next question is, how do I go about determining what I need to ask for in terms of the number of machines, the memory on those machines? How do I know what I need? And it's a tough question, but we're going to propose a methodology for you. Now, in order to make this a little more interesting, we're going to look at this problem in the context of a fictional case study. So I have a fictional company, Trey Research, and Trey Research is an online portal that will give health forums, doctor reviews, hospital locations, and also an online pharmacy. And so their software system includes 4 web servers with ASP.NET, and they currently store session state in SQL Server. They have 2 application servers using WCF, and they have a clustered SQL Server with 32 gigabytes of RAM. Now, the challenges for them are that they've had some performance and availability concerns. Occasionally, someone will lose a shopping cart. Occasionally, a page will take several seconds to load, and it's not a good user experience. And on top of that, they expect that they may have 2 million new users over the next 6 months. So what is already a somewhat bad situation could become a lot worse if they don't address it. So we're going to take the approach of, how do we help Trey Research to use AppFabric caching to solve this problem, and how do we make the best recommendations for them in terms of how to set it up? I'd like to point out that this is the fixing a existing application scenario. Obviously, you could go in new application design, and you could put caching in there right away and have the benefits so that you don't have to worry about it later. I'd also like to point out that we're talking about ASP.NET a lot, but caching can be used with any .NET application. So you can use it from your WCF services directly. You can use it through ASP.NET directly, or you can use the session state provider that it provides for caching with ASP.NET. So just want to make that clear because I do talk a lot about ASP.NET in the talk. Okay, so even if you don't know anything about AppFabric caching, if Trey Research came to you and said, hey, I really need to use caching to improve performance, I'm having all sorts of problems, you would probably come up with questions very similar to these, because these are just sort of obvious questions if you've worked with application development before. Where is the problem? Is this a problem in your forms part of your application? Is it a problem in your shopping cart? Is it a problem with your doctor reviews? Is it on the web tier or the database tier? And how many concurrent users have to get on the system before you start seeing the problem? Or is it just slow all of the time? So these are questions that you could ask, that I could ask. We don't need to know anything about caching to ask these questions. Also, with workload and mix, is this a mostly read-only workload? Is it a read-write workload? We all know that these types of issues can lead us to the right solution. And so what we'd like to present is a way of thinking about these systematically and of answering them in terms of AppFabric caching. You could get all of the answers, but if you don't know how it applies to AppFabric caching, it's not going to do you much good. So a lot of the questions I just said are in the first 2 points here. The first 2 steps of the process: identify potential caching candidates, and where are the bottlenecks? And then evaluate your current workload. If you do those things and you collect really good data, you can make some estimates for, I need 20 gigabytes of memory. My caching requires 20 gigabytes of memory. But that's not the whole picture. It's not just a matter of coming up with a memory figure. You've also got to look at things like your physical infrastructure. Are you using virtual machines or physical servers? For SLA requirements, do you have specific performance or security requirements that we're going to have to factor in and try to use the best features of AppFabric caching to meet that? And then finally, there are specific features for AppFabric caching. There's configuration settings that come into play here. You've got to account for those as well. So at the end of this methodology, what you want to have is a number of servers, the amount of memory on those servers, the network bandwidth that you require, and then also the configuration settings for caching. Okay, so let's identify first where the bottlenecks are. So I'm sure that all of you have tools like SQL Server Profiler for database analysis. And Perfmon and Performance Monitor can tell you application and server-based counters. And tools like Visual Studio Load Testing can give you even more data about where the potential problems are. And you might profile your application even and see what specific functions are slow. There's a myriad of third-party applications that will do the same type of analysis. The goal, of course, of using all of these tools is to find out where the problem is. So is there a hot stored procedure? Is there a procedure you call all the time? There's a lot of contention around it. Are there slow-performing pages or service calls? And when you identify those slow areas, those are areas that potentially could benefit from caching. So let's categorize the different types of caching that you might have. There's reference which is read-only, shared across users, like a product catalog. There's activity, which is read-write per user. And that would be, a classic example would be a shopping cart. I add things to my shopping cart. It's my shopping cart. It's temporary. It's activity. And then resource-related cached items are things that are read and write shared across users. And the forms is a good example of that. I can write to the form. You can write to the form. We can all read the form. Now, you might wonder, what's the point in categorizing my data like this? Well, it leads to the next step, which is understanding your workload requirements. Because if I categorize something as reference data, there's a good chance that's a high read-only workload. I might write to it one time during the day. I might read it thousands of times. The shopping cart might be 50-50. And if you understand your read-write profile and if you understand your read-write frequency, you can have data that we can use later in the process to come up with memory requirements. Also, when you're going through this part of the process, if you say, oh, this store procedure is super slow, it takes a minute to come back. If you're only calling that once every 30 minutes, you're not actually solving a problem that's related to the performance issues you're seeing in your application. So you got to back up. You can't just say, oh, well, cache this, 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 and this before you actually understand what the data says. And, of course, you need to look forward. What are your future needs? What's it going to look like 6 months or 12 months down the line? So once you've gotten all of that data, you need to come up with an understanding of what are the maximum number of active objects to be cached, which is a very confusing statement. Basically, what I'm trying to say is at a peak point of usage, you have most users are hit. It's your peak time of day. You've got a ton of users on the system. What is the maximum number of active objects you're going to have in the cache? Because that's going to determine how much memory you need to support. So an example would work well here. Let's say with Trey Research, with our case study, they have a shopping cart, the ability for you to purchase medications online. And that's stored in session state. So if during a peak time they have 25,000 concurrent users, that's 25,000 shopping carts. Now, even if the user logs on, creates a shopping cart, and closes their browsers, that object's going to stay in session for another 30 minutes. So we have to say how many new users are going to come in during that 30-minute period, because that's going to add to the number of objects that are active, that haven't expired, that can't be removed from the cache. And potentially the user closes their browser and opens a new browser and creates there's still the same concurrent user, but they created a new browser session. So, these are just estimates. You'd have to use the data from your organization to get good numbers for these. And then account for future growth, we'll say 25%, another 6,000. And so we come with a total number of maximum number of active objects as 35,000 objects. Again, right now we're just doing this for activity data. You could do this for as granular as you want. You could do it for activity data, then a product catalog, or all of your reference data together, or everything together. Obviously, if you just lump everything together, you're going to get probably a less specific estimate in the end. But you can basically handle this part how you like. Now, that 35,000 maximum active objects don't do you any good unless you multiply that by the average size of the object. Now, average object size is complicated for two reasons. One, your shopping cart could have one item in it, it could have 20 items in it, and they're going to vastly differ in size. So you're going to have to come up with a guess based on user patterns. What's a good average? The second thing for AppFabric caching that you have to consider is that it stores a serialized version of that object in the cache. And it uses a Net Data Contract Serializer class to do that. That serialized form of the object, it could be a lot larger than you expect. So you may underestimate, for example, how big that each object is, even after you come up with what the average size is. So there's two ways of handling that. I'll show you in the white paper that I'm going to show you at the end. There's some code that I've given you that gives you a rough estimate of what the serialized size is. And you could run your objects through that code. You could also just do a test on a test AppFabric cache cluster, add the item to the cache cluster, look at the statistics for the cache, and it will tell you what size that object is. So it's two ways of getting a good guess for what the post serialization size is. All right, so we've come up with this serialized object size. I'm going to divide this into activity data and reference data. Let's say we have 250 kilobytes and 60 kilobytes. There's an overhead per object, 0.5 kilobytes. And then we have the adjusted average serialized object size, just adding those two numbers together. The maximum active objects, which came up in the previous slide, will give us a total caching memory requirement when we multiply of 8.2 gigabytes and 4 gigabytes. Now, that's our first stab at our memory requirement. But there's one caching feature that's very commonly used, which is high availability. And we're going to talk about other caching features in a little bit. But high availability will create a backup of your object in the cache on another server, so it obviously doubles the amount of memory you would need. So I'm just pointing this out here because it's common. And if I wanted that on my shopping cart, because I don't want anybody to lose their shopping cart, I don't want to lose a sale, then that would double that memory requirement. Now, there's also some internal data structures overhead for regions and notifications and other caching internals. And we're just going to say 5% just to have a buffer. So our total memory requirement is 17.2 gigabytes for activity data, 4.2 gigabytes for reference data, for a total of 21.4 gigabytes. Now, I've got my memory requirement. It's time to step back and take a look at some of the other considerations before I say I need 4 servers or 5 servers. The first consideration I'd like to talk about is the physical infrastructure. Physical infrastructure involves what types of servers you're using. Are you using physical servers or virtual servers? If I have 2 virtual machines and they reside in the same physical box, if that box goes down, then I've lost 2 servers, basically 2 nodes in my cache cluster. So you have to be aware, if you're using virtual machines, of where those are going to live. We had one customer who could guarantee us that they could keep each virtual machine on a separate physical server. And in that case, they've minimized that risk. If you're using existing hardware, you just want to catalog what that hardware is. How many CPUs does it have? What's the speed? What's the memory? What kind of network card does it have? Just so that you can use those in calculations later. I would like to say that caching is designed to be used on commodity hardware. So you don't have to use high-end hardware for each cache server. I mean, that's somewhat of the point. We want to be able to throw commodity machines at it and add memory to the cache cluster without a lot of expense. And then you want to understand your deployment topology. Where is the application server related to the cache server, related to the database server? I mean, this is just sort of an obvious question of performance. So just taking a closer look at network. When you look at the network load, everything is in memory and everything is going over the network. So you want to make sure that your network can handle the incoming requests. So I may have a situation where one cache server can handle all of my memory requirements, but because of how often I'm writing to that one cache server, it can't handle the network load. And so if you understand things that we've collected earlier, like the number of reads and writes per second and the average object size, you can quickly sort of make some calculations to determine, are you going to overload the network card or the network along the path. And so that's another important point to make. You need to make sure the whole network path can handle it, not just the network card. So if I add servers to my cache cluster, obviously, if the load is distributed across those 3 servers, the network load on each server goes down. All right, so we've looked at our physical infrastructure. Now I want to talk about SLAs and manageability. It's possible and common to have one cache cluster that supports a variety of applications. Now, let's take our Trey Research case study. They've got their online pharmacy that gives them most of their money. That pays for the whole thing. So that's sort of mission critical. We don't want to lose sales. We want to make that as easy as possible for users to use. If they create a cache cluster and the online pharmacy uses it and the forums use it, if the forums estimates are done poorly, we totally underestimated how much memory the forums needs, the forum's usage of the cache cluster, that shared cache cluster, could exceed a high watermark, which we'll talk about in a second, and will trigger eviction across all the caches, including the online pharmacy. So if you understand that, then you understand that a mission-critical application may require its own cache cluster. Even though one cache cluster could support the memory needs of all your applications, it might not meet your business requirements. So the point of this slide is to think about the business requirements too, because that leads to an accurate recommendation. You also need to look at your key metric goals. Yeah?
So if you have, say, 3 caches on the cache cluster, you can't give priority to one over.
The question was, if you have 3 caches on a cache cluster, you can't give priority to one of the caches. There's not a way of saying, this is my high priority cache, or to prioritize them numerically. The only thing you can do, and which is one of the things that I'll recommend for Trey research in this fictional case study, is you can make certain caches non-evictable. And so it's sort of all or nothing. You know, I could say my shopping cart, and in this case I would recommend that. My session state cache that I'm using for session state, make it non-evictable so that at the point that memory is exceeded, all of the other caches are affected but that one. It wouldn't evict items from that cache. But you can't prioritize them like, you know, top, high, low, medium priority. If that makes sense. It's really non-evictable. So if you make even if you make one cache non-evictable, you can continue to add items to that cache until you reach the limits of the server memory. And then you reach a condition called throttling, which I'll show a demo hopefully at the end. And at the point that you throttle, you can no longer add anything to the cache cluster. So it really is non-evictable. It's going to honor your request, which is why you have to be even more careful and maybe even a little more generous with your capacity planning estimates, because you don't want to hit the throttling condition. Sorry, I missed that question.
So if it's non-evictable, is it up to the developer to say when to remove that from the cache, or can I put a file on that?
Oh, I see. Yes. There's a default expiration that you can put on each cache so that if a developer doesn't specify, they add an item to the cache with no expiration time, it'll default to whatever you say, 10 minutes, 30 minutes. There is also the ability for the developer to say, I want this to expire in 3 weeks. And then the cache will just, will honor that as well.
Can you set memory limits on the caches?
The question is, can you set memory limits on the caches? There's not an option to set a memory size per cache. You can set a memory size per cache host, but you cannot prevent a cache from growing above a certain size. So these are all really good questions, by the way. The other thing I want to point out here is that for operational needs, you need to take into fact security is per cache cluster. So if you want to use encrypt and sign security and you want users to be authenticated to that cache cluster, it's based on the cache cluster, not the cache. So I could give this side of the room access to my cache cluster, but they'll have access to all of the caches. Now, the flip side of that is they have to know both the cache name and the key in order to access the data. But if you really want security in your mission-critical application and you only want this side of the room to have access to that, and you want everyone to have access to cache, to the forums cache, then you're going to have 2 separate cache clusters. Now, that may sound inconvenient, but we're normally talking about web servers and application servers talking to the cache cluster, not individual people. Yeah? You do. You have to explicitly give each user access to the cache when you're using encrypt and sign, when you have security enabled. And there's a situation, and I'll have to double check to see if they've addressed this yet. But I don't think you can give access to a group. So you can't just say this group has access and then add a bunch of people to the group. You'd have to actually have a user that you give access to. No, that's still per cache cluster. So you grant access to the cache cluster to a particular user. All right, so let's move on so we can get to some of the demos. The configuration settings. We've got a memory number. We've looked at our physical infrastructure. We've looked at our SLA requirements. Now is a good time to look at some of the features of AppFabric caching. Because now we have enough information to say, yeah, that feature would work for me, and this feature, probably I don't need it. So this table is a little bit confusing. I don't want it to confuse you. The feature for caching is on the left-hand side, and these are just some of the features, not all of them. And on the right-hand side is the requirement in our case study. It's not just a general requirement. So for Trey Research, these are the things they picked. I don't want to go through all of them. I don't think we have time, but I want to highlight a few. Trey Research decided they're not going to use regions, but I would like to talk about regions. A region is a named region within a cache. So I can create a cache, and I can create any number of named regions within the cache, and that gives me the ability to use certain features like tag-based searches and other things that are a little more advanced for caching. Also, I can separate my data. I could have region A, B, and C and put what I want in each region. The reason I'm bringing regions up in capacity planning is that regions exist on one cache server. So if you put everything in your 20 gigabyte cache into one region, one named region, then that you would have to have each cache server be larger than 20, able to support 20 gigabytes, because it takes that whole region and exists on one server. Now, that doesn't mean that lots of people say, well, then you lose your distributed cache, the whole point. It's actually, what they expect you to do is to have either no regions, and then caching will distribute your items evenly across the cache cluster, or to create multiple regions, or a region that's just a subset of your total memory needs. Because if you create multiple regions, it will load balance those regions across the different cache servers. But you need to realize this, because you can't just put everything in one region, and you need to estimate the size of your largest region. So if your developers are developing applications that create and use regions, what is the largest size of the largest region? Because that's going to determine the amount of memory you need on each cache host. Each cache host would have to host the largest region. So just want to stress that. High availability is another one. And like I mentioned, it creates a copy of your items, very desirable. Two things here. One is you need enterprise server or higher for this. And so we've had customers say, hey, I already bought my servers, and I can't get high availability to work because I don't have enterprise server. Well, I don't want that to happen to you. Make sure you use the right servers for this. The other thing is you need at least 3 servers. We had somebody on the forum say, hey, I got my IT guys to give me 2 servers. That's all I need for my cache, the memory requirements. But it's not all you need for high availability. Because if I have 2 servers and I have a primary and secondary copy, and one server goes down, now I only have the primary copy. There's nowhere to put another copy of that item, and per the rules of caching, it's not going to let you write to that server. So you have 3, so that if one goes down, all of the items that were a primary get copied onto the other server, and you can continue to have high availability. So if you, when you're factoring in your requirements, if you want high availability, you got to have at least 3 servers in your cache cluster. OK, so this is one of the more important slides to understand, because it's not just, hey, Trey Research needs 21 gigabytes of memory, so I'll get 3 8-gigabyte machines. It's not you're not using all of the memory on each machine, so you need to understand what the defaults are and what the implications are. So when you install AppFabric caching on a server, it allocates half of the RAM for that server to the cache memory. And so if I have a 16 gigabyte machine, it would reserve 8 gigabytes of that for caching. Now, you can change this. There's a set cache host config, and you can change this setting to say, hey, I want to use 12 gigabytes for caching instead of the default of 8. Sometimes that's fine, but due to issues, I'll show you a few, of garbage collection, where you're adding a lot of items to the cache, and the garbage collector is periodically running, your actual service for caching on each box will use a lot more memory than the amount of memory your caches are using. And so you want to test thoroughly if you're going to change the default setting from half. You want to test that thoroughly to make sure you didn't underestimate the amount of total memory you needed. The other thing I'd like to point out here is that you want dedicated servers for your cache servers. You can create cache hosts for each web server. You could have a web farm and put caching on each one of those servers in the web farm, and that would work. But what we've seen in support calls and in forums issues is that, hey, I'm suddenly seeing some service problems, or I'm suddenly seeing a crash here, or I'm suddenly seeing out-of-memory issues. And because you're mixing up your web services with your caching service with any number of services, it's very hard to troubleshoot. So I would recommend, and it is the supported scenario, to use dedicated servers. All right, so let's just go through this. You have a 16 gigabyte machine. 8 gigabytes are reserved by default. Let's stick with the defaults because we want to be safe. There's a low watermark at 70%, and that's configurable too, but let's just leave the defaults. And a high watermark at 90%. You add cache data, you add shopping carts, all sorts of things, and eventually you cross the low watermark. When you cross the low watermark, nothing bad happens. It evicts expired objects you can't even access anymore. So great. When you cross the high watermark, it starts to worry that you're running out of memory, and it begins to evict non-expired objects, the least recently used ones. So that's a bad thing, because then potentially somebody's lost their shopping cart, or potentially, if it's evictable. Or potentially you've lost data and the user experiences slowness or bad performance or errors. So we really don't want to cross the high watermark and cause this eviction, the forced eviction, to occur. So what we recommend is to target the 70% low watermark. And so in that case, if you're sticking with all the defaults, it would be 70% of 8 gigabytes, which would be 5.6 gigabytes. So if we stuck with that estimate, we would have initial memory per machine is 16 gigabytes. Half of that would be 8 gigabytes. 70% is 5.6 gigabytes. And dividing that by our requirement for Trey research, which is 21.4 gigabytes, we would get 4 servers. So we'd have 4 cache servers. Now, that covers a couple things. We said we wanted high availability for the shopping cart. That covers that because it's more than 2 servers. It's 4. And it's also a buffer in terms of the amount of memory we have for forced eviction and garbage collection. So those issues that I just talked about, the fact that we stuck with the defaults means that we're covered in that case. If you added memory to an existing box that was configured? I have not tried that, but I'm almost certain that you'd have to change the setting. I think that's a setting, because it's a setting on the cache cluster. I don't think it revisits it because it detects new memory. You would have to then change the setting yourself. And there's a set. I'm going to show you at the end with our demos. I'm going to show you the different Windows PowerShell commands. One of them is set cache host config. And set cache host config will change that memory setting on the box for how much memory you want to use for caching. All right, so Trey Research, we recommend that they have 4 16 gigabyte servers, that they spread their caches across those servers, that their shopping cart cache should be non-evictable, which is what somebody brought up earlier, thank you, and that their medical documents cache and their other caches are evictable, and they all share the same cache cluster. So that's sort of an overview of the thought process, the questions you ask, the math you do. I wanted to take a quick moment and show you the white paper, and then also point a tool out to you. OK, so this is the Windows Server AppFabric Caching Capacity Planning Guide. It goes over a lot of the information that I'm talking about today, and in more depth and more detail. So I encourage you to look at that. For example, if you go to step 2 on evaluate the current workload patterns, it provides a code sample for doing the serialization and determining the size of the post-serialized object. I will warn you, this is not a perfect estimate. I've compared them, and they're close. Sometimes they're a little further off than others. So if you want an exact estimate, you can, again, add the item to the cache and say get cache statistics from Windows PowerShell, and that will tell you exactly what size that object is post-serialized. The other thing that the white paper goes through is a capacity planning tool. You have a spreadsheet that I've created here that lets you plug in your numbers and does the math for you, basically. So everything we were doing in these slides, you could do in the spreadsheet. And I'll open it up here. You see, everything that's light blue, you fill in. And everything that's black is automatically calculated. So if I have a 16 gigabyte server, 8 gigabytes cache size, 70% watermark, it goes ahead and does the math and figures out how much memory I have per server. And it provides columns here to fill in. So down here, you can see it came up with the same thing that we came up with on the slides. But what you could do is say, I also have forums cache, and the average size is this, and the number of objects is this. And that will create additional memory, and it will aggregate that memory into a total memory requirement and come up with 8 servers instead of 4. So it's just a faster way of plugging in things. If I cache this instead of that, how many servers do I need? If I have an 8 gigabyte machine with 4 reserved, I now need 16 servers, things like that. So I'm hoping that this is helpful if you go through the process where you don't actually have to sit down with the calculator. And it also reminds you of a few of the things we talked about, such as high availability requires 3 servers, and each cache must support the largest region, other things like that. So this is available on the Download Center from a link in the white paper, and the white paper also talks about how to use it.
High availability, you can also use the regions, right? You use regions.
Yeah. Yes. The question is, can you use regions in high availability? And you can. So those regions then would just get copied onto a secondary copy on another server as a whole. So you'd have your primary region, and that region would exist as a backup on another server.
If it is just a reference data, can you set the memory settings to be higher?
Yes. The question is, if it's reference data, can you set the memory settings to be higher? I would say yes, but test. Make sure that it works. But if it's reference data, the implication is that it's mostly read-only data. And therefore, your read-only workload is going to tax the garbage collector less. You're not constantly writing things to the cache cluster, forcing the garbage collector to run and to keep up with the collection. Therefore, you probably can increase the size of memory per server, but test it out.
The write of memory, is that synchronous? It has to have an acknowledgement back that it was actually in memory? Or if it's transaction?
The question is, does it have to have an acknowledgement that the item's been written to the cache before it returns? I guess I have to say I don't know. I haven't verified that, but I assume that's the case.
So what I'm getting at is, if you had multiple data centers, would it be more beneficial if you wanted to go to, say, some sort of hotspot scenario to write it to both locations or to do cache mirroring?
OK. So the question is, if you had multiple data centers, would you want to write it to both locations yourself, or would you want to mirror the cache cluster? Trying to think. I haven't done that scenario. So I can't say for sure. I wouldn't want to guess. I'm sorry, what was that?
You access it through the concurrency model
Okay.
in your persistent. As you're persisting that object to the database, persisting it up to the cache, you're going to check your availability, persisting it back, concurrency model up to the database. One of the things that you should check some of those properties, determine whether to actually
Okay.
persist.
So the comment here is that you would go to the database and persist it in the cache, or put that in the cache as well through the concurrency model?
Yeah, the concurrency model of the AppFabric cache.
Oh, okay. Right.
As you're checking that and setting that initially,
Mm-hmm.
you're dealing with things to do a callback on that and check that before you destroy the object or read the object.
Okay. Okay. Thanks. All right, let's go back to the slides here. Okay, so for a few minutes, I would like to go through the detailed performance and scalability data that Grid Dynamics collected. And you can use this white paper that they created and these test results in two ways. One, you might want to say, is caching going to work for me at all? Does it perform the way I want it to? Look at this white paper. It's got performance numbers. If it doesn't meet your expectations, you don't have to use caching. If it looks like it meets your expectations, you can proceed to the next step and test it in your scenario. So there's a link here to the white paper. And the way they did the testing is that they varied one or two variables per test so that they could see the result of that variable. So for example, when they're doing cache data size, they'll vary the amount of data stored in the cache, and then they'll do a series of reads and updates and writes and say, hey, if we're storing 20 gigabytes in the cache, is that slower than if we're storing 40 gigabytes in the cache? Or for type complexity, they'll say, is it faster to store a byte array in the cache than it is to store a complex shopping cart object? And the answer is, it is faster, but they ran some tests to try to determine where the speed, where the best performance could be found and what that performance looks like. So for their testing environment, this is a picture from their white paper. They used Visual Studio load testing. They created a series of agent boxes to produce enough load to load the cache cluster. And they have 1 to 12 caching nodes. So in their cache cluster, they have 1 to 12 cache hosts, cache servers. And they can select, I want to use 3 for this test, or I want to use 12 for this test. And then they can get various results from this different size cluster, different size data, and everything's run through Windows PowerShell and Visual Studio load testing. All right, so for Grid Dynamics, this is an example of one of the charts that they came up with. There's lots more tests, detailed tests in their paper. But I'd just like to point out a few things. One is that this particular test was storing a 16 kilobyte byte array, and it was doing 90% reads and 10% writes and using the default security. And what it shows is that based on the number of nodes in your cache cluster, like 2 nodes all the way up to 12 nodes, caching scales linearly, basically. So the other thing that I'd like to point out is that they talk about high and balanced and low throughput. And the definitions of those are that at some point, your throughput continues to increase until your latency starts to increase. And at that point, you can push it a little bit harder and at the expense of latency, about the amount of time it takes for requests to come back. And that's what they can term high throughput. High throughput is like, what's the maximum I can get out of this while sacrificing a little bit of latency? And then their balanced area is sort of a sweet spot, and low means that they kept the throughput at a level that got the best latency. So in this chart, it's showing high and balanced, and there's not usually a tremendous difference between the two. OK, so security is something we've touched on a couple times. I want to look at these charts because it points out something important. If you have 3 security options. You have encrypt and sign. sign, and none. And this chart will show that in 3 nodes, 6 nodes, and 12 nodes, the obvious fact that if you have no security, everything is a lot faster. Now, that may not be an option for you, but maybe it is an option for you, and if you just use the defaults and you're not considering it, you're not aware that you can get a much better performance with no security. Now, the only way it could be an option is if you had other security measures in place, where only the web servers could access the cache cluster, nobody else could, and you turn off security. But that's up to you. I just wanted to point that out, that security does take time to encrypt and decrypt and to sign. You can also see on the bottom chart that none utilize the cache cluster the most. Utilizes the resources the most, both CPU and network. These are some other example charts from their white paper. You have 12 nodes, and you vary the object size. As the object size increases, obviously it takes longer to transmit that over the network. It takes longer to encrypt and decrypt it. And so your throughput dramatically decreases based on object size. The one thing that you can get out of these charts, because it's kind of obvious that the larger your objects get, the longer it takes to transmit. But the non-obvious point here is that there's a sweet spot for medium-sized objects. That what Grid Dynamics found was that very small objects are not as efficient to send across. Very large objects took a lot longer to encrypt and decrypt and took a lot more of the processor time to do that. Medium-sized objects up to that 128 kilobyte range seem to perform the best. So it's not something you have to pay attention to, but when you're trying to eke out every bit of performance, it might be helpful. These are just some of their other conclusions. A lot of these conclusions we touched on. And the one that I wanted to point out was that the high type complexity also influences the client-side performance. So if you have a type that's very complex, lots of sub-objects inside sub-objects and sub-objects, and maybe a little larger, that's going to take some time to encrypt on the client side, and therefore there's some CPU resources needed on the client side to do that work. So when you're looking at your solution, if it's not running quite as fast as you thought it would, maybe also take a look at how much time is being spent when you profile on this type of activity. And the one way of doing that, an easier way of doing that, turn off security and see how fast things fly. And maybe that, or see how that affects the client-side CPU. Maybe that would give you a clue as to whether that's the issue. OK, so this last section is actually my one I was looking forward to the most, because I'm going to show you some demos. And it's mostly going to be all demos, and then I'll open it up to questions. Basically, this is an iterative process. You come up with your number, and then you've got to look at it and test. You've got to look at it in production. You've got to tweak your numbers, add a server, add some memory. You know how it goes. We can't ever come up with a process that's going to give you the exact right answer the first time. So what we're going to do is I'm going to show you some tests that show some problem scenarios. And then we're going to use perfmon and some other tools to actually troubleshoot them. So what I've done, the Grid Dynamics has their test code out for download on their white paper. I downloaded that, and I tweaked it to work on my machine. I have to warn you, if you do that, there's a lot of tweaking you have to do. I mean, there's a lot of hard-coded server names, and it wasn't the easiest experience. So I want to give that feedback to Grid Dynamics, and hopefully they'll make that easier to use. But I'm using the same thing they used for their white paper, and I'm just running my own tests. So what I'm going to do is I'm going to say when you start Windows PowerShell and you have caching, I have caching installed on my laptop. So I have a one-node cache cluster. Not very realistic, but it works for the tests. So I'll say use cache cluster, and that will give me access to all the cache cluster commands. Then I'm going to say git cache host. And that will show me I have one machine in my cache host, and it is my laptop. So the next thing I want to do is run a demo. So I'm going to say demo eviction. This is a PowerShell script I wrote that's going to set up a few things. And one of the things that it actually sets up, I print out here, which are some global variables that Grid Dynamics uses to more easily run their tests. So I assign my cache name to test cache. I say I want to use a byte array. I want each byte array to be 1 megabyte in size, and I want 150 of them in the test. And I want to do 100% get existing. There's an operational workload mixes here that have various workloads you can pick from. So in this demo, I'm just going to run this demo, and we're going to look in perfmon and see what's wrong. There's something wrong. So I'll say start load tests with an S at the end. And it goes through. It starts the number of cache hosts that you specified you wanted to start for the test. It loads the data for the test. In this case, my 1 megabyte arrays. And right now, it's filling the cache cluster with items. And now it's running get existing requests. So it's doing gets on all of those items that it preloaded, just to see what's the performance of those gets. Instead of actually looking at some of the charts that they made and some of those, I want to troubleshoot. So I'm going to go over to perfmon. And if we look at available megabytes, we'll see it decreased as it was filling the cache. But I still have over a gig. This is available megabytes for memory. If I look at total data size bytes, this is a AppFabric caching host counter. So it's for the actual machine itself. I see that it increased a little because it was populating the cache. And it's at 150 megabytes. But if I look at some of the other counters, one counter you want to pay attention to is total eviction runs. Now, if I look at total eviction runs, I'll see that total eviction runs are increasing every second. Every second, there's a new eviction run. And if you remember back to the memory slide, eviction happens when you cross the high memory threshold for your cache host. So the strange thing is, I've got plenty of memory on the box. I'm only using 150 megabytes for my cache. What's the problem? The reason I'm showing you this is to show some other commands in Windows PowerShell and sort of how you'd approach this. So if I go back to Windows PowerShell, do Control-C, stop my test. The test is done. What I want to do is look at the cache host settings. I think that's the first thing you should do when you look at something, when you see a problem like this. So just get an idea of how these hosts are configured. So get cache host config. I'm going to say localhost. And 22233 is the default port name number. So does anybody see the problem? What? 100 megabytes. Yes. I should have candy I throw at people. Oh, well. So yes, it's 100 megabyte size memory for my cache, for caching on this box. And I went to 150. And therefore, the evictions are just running through the roof. Now, why, if I am running evictions, is my total memory evicted 0? Any guesses? My total memory evicted is 0 here. Nope, not quite. Yes. So if I say git cache config, test cache, we'll see that eviction type is set to none. Okay, so eviction type should be set to LRU, for at least recently used. If it's set to none, and it can be set to none on purpose, that would be a scenario where evictions are running constantly and you're never reclaiming the memory. So by understanding a little bit about the architecture, by understanding which counters to look at, we could say, hey, evictions keep running. We're never reclaiming memory. There's probably a non-evictable cache here somewhere. And in my deployment and management white paper, which I hadn't shown you, it's in the same section with the other one, there's some Windows PowerShell scripts to cycle through all the caches and show you which ones are evictable and which ones aren't. So if you had like a lot of caches, you could very quickly spot which one might be the culprit. OK, so let's run another demo here. This one's a demo on throttling. And I briefly mentioned that throttling, so you might know what's going to happen. But basically, it's the same scenario, but this time I'm going to add 3,000 byte arrays. And by the way, the tool actually, once you get it running, is cool because it stops your cache cluster. it restarts it. It only restarts the number of cache hosts you specify if you had a lot. So it's convenient for running a variety test, but it is kind of hard to set up. So you see here, it's filling my cache cluster. And if we look here, available, well, let's not do that one. Let's go here to total size of my cache. Continues to increase. My available megabytes continues to decrease, as does my time left for the demo. And eventually, we're going to get to a situation where the box is so low on physical memory that we hit a condition called throttling. And the way you can detect throttling, first of all, if I look at eviction runs, well, let's see, eviction runs are not running yet. Let's go back to here. The main thing you need to pay attention to for throttling is the event log. So if I go to the, well, you could guess, too, that your machine is so low on memory, you could guess that you're hitting throttling. You also get throttling exceptions. So from code, you would see exceptions from data cache exceptions that say you're throttling. But the event viewer will point this out to you. So if I go to the event viewer, I'm low on memory here. Refresh. I should have had that up already. All right, if I click refresh, what I'm looking at right now is application services and logs, Microsoft, Windows, application server system services, operational. Now, you have to enable this. I don't know why it's disabled by default. I would enable it if I could, but you have to right-click and say Enable Log before you do any type of monitoring. I've listed this in the management and deployment guide, too. If I do a refresh here, what we'll see is that we have, down here, it says service entered throttled state, and that's event ID 115. The other thing we'll see is that from our previous test, down here, it says service available memory low. Now, in our previous test, we weren't entering in the throttle state. We had plenty of memory on the machine. And it gives you a list of percentages here. So in this case, our available memory percentage was 42%. Great. That's great. We have plenty of memory. But our cache data size percent was 1. We only had 1% left to use in our cache. And so these numbers, these percentages, actually show where the problem might be. Whereas if we go up to our current test, slowly, we will see that available memory percent is 4%, and that's why we're entering the throttled state. So we enter the throttled state, no requests would then be accepted, and basically this is not the situation you want to get yourself into. So if you keep track of the operational log, this is probably a key area. Enable it, look at it, run your tests. If you see service available memory low, maybe you got excited and you increased your cache size too much and you're running into to some issues and you got to back off on the amount of memory you reserved for your cache on that host. Or maybe you have a non-evictable cache and you're adding too much information to it. OK, so these are listed in the deployment and management guide, this step for looking for throttling errors. Now I want to do one more demo. And luckily, my machine will come back to normal. There is. The question is, can you clear a non-evictable cache other than rebooting the box? There's two answers for this. One, if it's the only cache on the, if you're OK with doing that, you can restart the cache cluster. So there's a restart cache cluster command. It restarts the cluster, the entire cluster, the services on all the machines. If you had other caches on that box and you're like, I really don't want to do that, you don't really have an option of clearing a cache from Windows PowerShell. You can't restart you could delete the cache, but that's probably not going to do good things for your applications that are trying to use it. The other thing you could potentially do as a hack would be to use regions and have a way of programmatically clearing the regions. And actually, there's a call where you can say get system regions, and you can clear all the system regions. But again, you're clearing all the data in your cache cluster at that point. So that's the two things I could think of. All right, so I am running out of time. Basically, what I'm doing here is updates. And if I go here to perfmon, I just want to quickly show you that I'm doing a very high update workload. I'm going to do, and I'm going to take some questions while I show you this, but I'm doing a very high update workload, and what we'll see is that the oh, I got to get my counters. All right, let's start that one more time. OK, so while this runs, what you're going to see is that you're going to see generation 2, 0, 1, and 2 collections happening as the memory keeps on getting up, as more and more memory needs to be garbage collected. So the very high updates, if you look at these garbage collection counters for generation 2 collections, 0 collections, 1 collections, it does 0, 1 collections frequently, 1 collections infrequently, and 2 collections the least frequently. And the generation 2 collections actually can temporarily pause things, which is why you just want to keep an eye on it and see how often they're happening. It probably isn't going to be a big issue, but what we have seen is that you don't want to have a machine that's like 128 megs of RAM, and the server-based GC, garbage collector, will use all of that memory until it really, really, really has to do a collection. And then do a Gen 2 collection, and it will just collect and collect and collect, and it will take a while. So what we found is that probably a sweet spot is a 16 gigabyte machine if you want to avoid that kind of issue. We're looking at that, and we're trying to minimize that problem in the future. So I'm running this test. You can see the garbage collect. The only other thing I want to show you, because I'm over time here, is that private bytes is about 1,656,000, whereas the total cache size is about 1 gig. So I just want to stress, don't be surprised if your service is a lot bigger than your actual cache size. It's OK, and that memory will get reclaimed eventually. It's not a memory leak. But it's why it's harder to run other things like web services on the same box, because it just expects to use the memory that's on the box. OK, well, I'm done, and let me just go back here to the slides. There's other sessions on. There's another session on caching. There's some hands-on labs on caching, and there's also the AppFabric product booth. I'm going to be there later this afternoon if you want to talk more about caching. I'd love to talk to you. I'll be there from 2:30 to 5. And then there's also these track resources. So don't forget to complete an evaluation to win wonderful prizes, and scan the tag. So thank you very much. I appreciate you coming today.